Welcome to the first part of 3 about our trial in grapes, where we look to plant sap analysis, and in this part I will discuss the potassium influence on leaves and fruits. We tested the grape variety Souvenir Gris. We did that on 4 different fields, sampled every 2 weeks with a total of 12 times. Fruits were sampled from July 1st up until harvest. And on the picture on the right side you see the Souvenir Gris. Over here you can see the fruit development over time. So you see clearly that sugars start to go up once the coloration starts of the fruits. And as you can see, around mid-September there was a certain drop of sugars, and then eventually sugars came up again. And that had all something to do with the weather in September, because on the 9th and 15th of September we got 30 to 40 millimeters of rain, and that led to lower sugar, or basically higher water uptake in the fruits, which diluted the sugars, so that came down quite a lot, and eventually sugars start to move up again. But that's why the sugars show like a trend down and back up again. Overall sugars between the fields stayed around the same. The biggest differences came from potassium, because if we look to the potassium uptake in the leaves, and then especially of location V and location Z, which are the blue and the red line, then you see clearly the potassium uptake much higher than the 2 other fields, and the potassium came out also higher in the fruits. So you see directly a relation between the plant sap analysis of the leaves and the fruits. So the higher the potassium in the leaves, also the higher the potassium in the fruits. The higher potassium also led to a higher pH in the fruits. So we know from theory that the higher the potassium in the leaves and the higher the potassium in the fruits, that will lead to an increased pH. And that's also what we see over here. So the red and the blue line with the highest potassium showing also the highest pH compared to the 2 other fields. If we then look to the potassium availability in the soil, then if we look to location V and location Z, then the average potassium level in the soil was around the ideal level. But still that led to a way too high uptake of potassium, because the potassium came out much higher than our target values, which you see here, the maximum target value with the gray line. And if you look then to location K and location G, which are the green line and the orange line, those were on the soil balance analysis lower on potassium than the ideal level. But still, if we then look to the plant uptake, it has always been enough. Maybe the young leaves could be a little bit better, but the overall uptake, if we also look to the old leaves, they were high enough. So basically, with a lower level of potassium, it will even lead to a better balance in the plant, like in this case. And the problem of potassium is not only that it leads to a higher pH in the fruits, but it also is antagonistic to other nutrients. And an example of that we're going to see with magnesium, because if we look to magnesium, then we see that there was a big difference on magnesium uptake, where there was one field came out much higher than the target values. And you see a picture on the left side where you don't see any magnesium deficiency, and on the right side you see an example of the field where you definitely saw a lot of magnesium deficiency, and that one also came out lower in the plant. And we also saw magnesium deficiency on location V. So over here the red line and the blue line both show too low uptake, and both show a lot of magnesium deficiency on the leaves. And location G and location K, especially location K, there was no magnesium deficiency visible. On location G, just here and there a little bit. But if we then compare the magnesium with the soil analysis, then it's interesting that location K is having the lowest availability of potassium in the soil, but it's having the highest uptake. So if you compare it with the three other fields, which were around the ideal level, and even location V came out higher than the ideal level, so you would expect a good enough magnesium uptake, but the one with the highest uptake was basically the lowest in the soil. And that's interesting. And if we then look to the potassium uptake and we compare that with the magnesium uptake, then you see very clearly that the higher the potassium, the lower the magnesium uptake. So here you really see the antagonistic interaction of potassium with magnesium. So potassium higher in the plant, or that the plant needs, will lead to a lowering or lower uptake or a blocked uptake of magnesium, as we clearly see in this data. And the green line was one of the lowest with the potassium uptake, and eventually the highest with its magnesium, even though it was not high available in the soil. And if we then look to calcium, the overall calcium uptake has been good for the young and the old leaves, all came out above the target value, so calcium was more than enough. But also here we see again that if we look to the calcium in the fruits, that the red line and the blue line, even though the levels are quite close to each other, but seem to be overall the lowest in uptake with calcium. And if we then look to the calcium availability, then basically there was more than enough calcium available in the soil. So it makes sense that the overall uptake was high enough. But if we then look to the potassium levels in the fruits and the calcium uptake in the fruits, then you see again that the potassium is also leading to a lower calcium uptake. And if we check then the potassium calcium ratio, then the higher the potassium calcium ratio, so the higher one potassium compared to calcium, that one also was the highest with the pH. So your potassium is really important to keep an eye on if we look to plant cell analysis, because the higher the potassium, the more it blocks your magnesium, the more it blocks your calcium in uptake. That will also lead to to lower levels in the fruits when your potassium is too high. So lower magnesium, lower calcium in the fruits, and eventually that will lead to a higher pH, not only in the leaves, but also in the fruits.